infrastructure, for instance, where you are, you're quite high, you're quite remote. Is that going to be factored into the feasibility study? I know you've done a pre-feas, but isn't this, you talk about being the lowest cost, right? You're very low cost, right? So can you actually deliver that?
Oh, yes. So let me go first to the infrastructure. The project, depending the perception, is not really remote. It's actually a few kilometers away of producing mines in Chile, okay? It's near the border with Chile, and we are in a highway that cut across, and you can look at it in our website. The highway cut across from the Pacific port to the Argentinian railroad line that goes to the Atlantic port. So and we have already built a road that we go from the mayor town to the project in a couple of hours. So actually, that's really not remote. It is elevated. It is high in elevation. Just to say, also, La Paz, the capital of Bolivia, is high in elevation. I mean, this part of the world, everything is high in elevation, the Puna Plateau called, and all lithium mines are at the same elevation, about 4,000 meters elevation. In that sense, in terms of remoteness, this is absolutely not the most remote project. It's actually less remote than most of the others, on one hand. On the other hand, talking about the operational cost, yes, this is one of the lowest operational cost projects in the world. So let me explain the operational cost because it's very important and it's not obvious. When you are talking about brine, you are talking about mining, but you are really extracting a liquid. And this is extremely cheap. So the extraction part is, I would say, irrelevant in all lithium projects. You just pump it. I say irrelevant, but not quite, because it depends on the productivity or the porosity of the salar. So some salars have low productivity. And a good example is, for example, the Olaroz project owned by Orocobre that requires many, many wells to actually extract the brine. The brine doesn't flow because of the porosity. In our project, it is a super productive salar that in 4 or 5 wells is enough for the whole production. But this is a minor part of the cost. The real operational cost in brines is settled in 2 aspects that are very, very important to understand. The first is grade. The lower the grade, the bigger the ponds that you have there. But it's logarithmic. It's not direct. That means, just to give you an example, that when you are below 400 milligrams per liter, you need areas that are so big that they become impossible to do. When you are in 200 milligrams per liter, it becomes silly. It becomes like, you need a whole province to actually be flooded with brine to be evaporated. So that is why you will see that in the market, some people are talking about other technologies because the current technology cannot do it. This is another story to talk. So one point is grade. The higher the grade, the lower the pond. The pond, have at the back, is 50% of the capex, okay? So you have lower ponds, or actually higher grade, lower ponds. Now, let's go to the next point, which is fundamental when you are evaluating a lithium brine project. Impurity, but warning sign. I'm not talking about impurity of the final product. I'm talking about impurity on the original brine, okay? So, just for people to understand, there are many natural resources that when they contain some impurity, the ore or the product that you want to extract become very difficult to treat. I will give you a couple of examples. In gold, arsenic and mercury are negatives because they are environmental challenges and it's a big issue. In iron, silica, for example, is also a big issue because they damage the oven and these things. In zinc, selenium, and so on. In lithium, the 2 elements that are the killer elements are very common in nature, magnesium and sulfates. Magnesium and sulfate in brines kill your lithium brine project, okay? So I give you an example. In about 1,000 salars, these sulfates that you have in the Puna Plateau, 1,000, well over 900 of them contain so much magnesium and so much sulfate that it is more expensive to extract the lithium from it than leave it in the ground. So those two elements are critical. People usually don't ask, but when you hear somebody saying, I have a lithium project, you have to say, you have a lithium project? Great. How about the magnesium? How about the sulfate? Okay. Now, our project is the lowest magnesium and sulfate project in the world, including producing mines, like, for example, SQM and Albermer and Leven and so on. So that is the secret of our low operational cost, because those impurities need to be removed. And there is a variety of ways to remove it, but all varieties include money at one point or another point, okay? So when you say, why Neo Lithium produce or claim to be able to produce lithium at lower cost? Because it has the lowest impurity content or critical impurity content in the world.